Close your eyes for a second. Think of the sea. You have a color in your head right now. Probably blue, maybe deep blue, maybe turquoise, maybe aquamarine, but definitely some shade of blue. Homer didn't. Homer, the ancient Greek poet who wrote the Iliad and the Odyssey about 2,800 years ago, the greatest text of Western civilization. And in both of those epics, across all 28,000 lines, Homer never once calls the sea blue. He calls it wine dark. Wine dark sea. Again and again and again. Never blue. 19th century scholars found this strange. Maybe, they thought, Homer was colorblind. Maybe ancient Greeks just had different eyes. So they checked other ancient texts, the Hebrew Bible, the Indian Vedas, the Quran, ancient Chinese classics, and they found the same pattern everywhere. No ancient culture in the world used a word for blue, except one. We will come back to that exception in a few minutes, because it changes everything. But first, the question. If all ancient people did not use the word blue, does that mean they did not see it? And if so, what colors are you not seeing right now? This is a story about how color isn't color. It is an idea that has to appear in language before it appears in your head, and about how in 2025, scientists proved, right inside the room you are sitting in, there are colors your brain physically refuses to see. This was first noticed by a man you might know for another reason, William Gladstone, four-time Prime Minister of Britain during the Victorian era, one of the most powerful men of the 19th century. But before he became a politician, Gladstone was obsessed with Homer. He read the Iliad and the Odyssey in ancient Greek every morning, made notes in the margins, compiled indexes, counted words. He was a Homer superfan long before he was a statesman. And in 1858, Gladstone published a study that nobody read at the time, but that 150 years later would become one of the most important discoveries in cognitive science. Gladstone counted every single color reference in the entire works of Homer. Here's what he found. Black, mentioned roughly 170 times. White, about 100. Red, 13 times. Yellow, 10. Green, 3 times, and always meaning fresh or young, not the color. Blue, 0. But this is not even the strange part. The strange part is how Homer describes colors at all. His sheep are violet. His honey is green. Iron is violet. Faces go green with fear. And of course, the sea is wine dark. Gladstone reached a radical conclusion. Homer wasn't describing colors. Homer was describing darkness and brightness. The ancient Greeks, in Gladstone's theory, did not see the world the way we do. They saw contrast, dark against light, shiny against dull. But hue, the thing that matters most to us, for them, barely existed. Gladstone thought this was unique to Homer. He was wrong. It was much bigger. In 1869, another scholar in Germany took Gladstone's idea and pushed it further. He started checking other ancient texts of the world. What he found was chilling. In the Indian Vedas, the oldest Indo-European texts, about 3,500 years old, there is no word for blue. The heavens are described, the ocean is described, but the color of the heavens and the ocean is never named. The Hebrew Bible, same thing. The word techelet appears, but translators argued for centuries whether it meant blue, purple, or just precious dye. Most modern scholars now think it was a color, but without a specific hue. The Quran? No Arabic word for blue as a standalone color. Only descriptors based on other objects. The color of the sky, the color of deep water. Ancient Chinese classics. The character Qing meant blue, green, black, and gray. One symbol for four colors that to us are completely different. Everywhere, everywhere, blue appeared in languages after all other colors, and almost always last. Except in one culture, the ancient Egyptians. They had a word for blue. Clear, distinct, precise. Khspd, blue. Why only the Egyptians? Because they were the only culture that invented blue. Around 2200 BC, almost 4,200 years ago, the Egyptians created the world's first synthetic pigment, Egyptian blue. They mixed quartz sand, copper, and calcium, heated it to 1,500 degrees Fahrenheit, about 800 degrees Celsius, and got a powder of pure, brilliant blue. When you have blue pigment in your hand, you need a word to name it. When you don't have the pigment, you don't seem to need the word. In 1969, two American anthropologists did something nobody had attempted. They tested 98 languages of the world for color terms, and they found a universal pattern, the same one everywhere. From Papua New Guinea to Siberia, from the Amazon to Africa. All languages acquire color words in the same order. First, black and white. Every language on earth has words for dark and light. Third, always red. Never green, never blue. Always red. Scientists think it is because of blood. Blood is the color you need to distinguish to survive. Blood means wound, means death, means hunting, means birth. Red is the first color humanity ever named. Then, green or yellow, in either order. Green means plants. Yellow means the sun or ripe fruit. Both survival colors. And only then, much later, blue. Blue appears in a language last, almost always, in 95% of the 98 languages studied. Brown, purple, pink, gray, orange, all of them come after blue. But blue itself, almost without exception, arrives last among the basic colors. And here we hit the question that changes how you think about your own vision. Why is blue the rarest color in language? Because it is the rarest color in nature. Think about it for a second. How many genuinely blue things can you name in nature? The sky, water, and that's about it. In the plant kingdom, less than 0.1% of flowers are actually blue, and most of the ones you would call blue are really purple. Cornflowers, violets, hyacinths, all closer to violet in the spectrum than to true blue. In the animal kingdom, blue pigment basically does not exist. The blue jay, the blue whale, the morpho butterfly, none of them are actually blue. It is structural color. Microscopic structures on their feathers, scales, or wings that bend light in a way that makes your eye see blue. But if you crushed a blue jay's feather into powder, the powder would be brown. Minerals? Lapis lazuli and sapphire, both rare, both precious, both historically worth more than gold. And the sky and water? They aren't things. They are atmosphere. They are background. You don't name the color of the background until you start manufacturing it. On cloth, on walls, on paper. Before someone invented blue pigment, there was no reason for a word. Before the word, there was no category in the brain. Which brings us to the question that broke cognitive science wide open. If you do not have a word for a color, can you see it? In 2006, one British scientist flew to Namibia to find out. His name was Jules Davidoff, professor of cognitive psychology at Goldsmiths University in London. He had spent years studying how language shapes perception, and in 2006 he got an idea. Go to a people who have no word for blue. In northern Namibia live the Himba people, semi-nomadic cattle herders, about 50,000 of them. They have their own language, distinct from every other language on Earth. And in that language, there are only 5 basic color terms. None of them is blue. But what is even stranger, the Himba have several different words for shades of what we would call green. What is one green to us is 5 different colors to them. Davidoff designed a simple experiment. He showed participants a circle of 11 squares on a screen, 10 of them the same color, 1 different. Task: find the odd one. First test: 10 green squares, 1 obviously blue. For you and me, it takes about half a second. Davidoff shows this circle to a Himba participant. He stares at the screen, and stares, and stares. Most of the Himba participants could not find the blue square at all. They were looking at a circle with 1 obviously blue element among 10 greens, and they saw no difference. And now, the second test. Davidoff swaps the image. Now all 11 squares are green, but 1 is a slightly different shade. For you and me, it is impossible to tell apart. They all look exactly the same. Same Himba participant looks at the new circle and instantly points to the different square. No hesitation. Immediately. What is impossible for us is obvious to them, and vice versa. This is the answer. Your brain does not see what your language has no word for, and it does see what the word is there for, even when the difference is objectively smaller. Language does not describe vision. Language creates vision. If you are thinking this is just about the Himba in Africa, I have news for you. The same effect is running in your brain right now. In 2007, Lara Boroditsky at Stanford University, one of the most respected psycholinguists in the world, noticed something unusual about Russian. Russian does not have 1 word for blue. It has 2. Sini for darker shades, goluboy for lighter shades. These are 2 completely separate colors in the Russian mind, not shades of 1 color, 2 colors. Boroditsky recruited 2 groups, 1 Russian, 1 English. She showed them pairs of blue squares. Task: same color or different. When the 2 squares were both Sini, both dark blue or both light blue, both groups reacted at the same speed. But when 1 square was Sini and the other was goluboy, Russians reacted faster. On average, 124 milliseconds faster. Not enough to matter in daily life, but in cognitive tests, that's a massive difference. And on other colors, red, green, yellow, there was no difference. Only blue. What this means? A Russian brain, physically, processes blue differently than an English brain. Not better, not worse, differently. If you have a Russian friend, their brain sees more shades of blue right now than yours does. And if you learn a new language with new color words, You are literally rewiring your visual cortex. In April 2025, a team of scientists at the University of California, Berkeley, did something no one had ever done. They did not discover a new color. They created one. In your eye, there are 3 types of color receptors: one for red light, one for green, one for blue. Every color you have ever seen is a mixture of activations across these 3. The problem is that in normal life, light always activates several cone types at once. It is physically impossible to activate only the green receptor without also triggering the others. Nature doesn't work that way. The Berkeley team used precision laser pulses to activate only the green receptor of their participants, one receptor at a time, and see what would happen. What happened was a color no human in history had ever seen. Participants described it as an absolutely saturated teal, a color that looks more pure, more saturated than any teal that exists in nature. The scientists named it Olo, from 0, 1, 0, because only the M cone was activated, with L and S off. Olo exists. It is physically real. Your brain can process it. You will just never see it, because in nature, that kind of light does not exist. And Olo is not the only one. Scientists know of other impossible colors, colors your brain could theoretically see, but that never appear in reality. Stygian blue, a blue so saturated it is simultaneously as dark as black. Self-luminous red, a red that appears to glow from within itself, like it is burning. Hyperbolic orange, an orange so saturated it exceeds any spectrum of light that can exist. All of these colors exist for your brain. You have neural pathways for them. You will just never get the right stimulus to actually see them. Homer saw the sea. He saw the waves. He saw the sky. But blue, for him, did not exist. Because the word did not exist. Because the pigment did not exist. Because in his head, there was no category. And now, look up. Look around the room. Right now, in the room you are sitting in, there are colors, entire categories of colors that you cannot see. Not because they do not exist, but because you do not have a word for them. What does not exist for you right now?